For decades now, mainstream media and climate alarmists have been telling us that man-made emissions are going to cause a runaway greenhouse effect. They claim that the science is settled, and further that 97% of scientists agree. Tom Harris has a master's degree in mechanical engineering with specialties in thermodynamics and fluid dynamics, two of the disciplines most qualified to assess our coming extinction via environmental disaster. For many years, Tom was an advocate for the global warming movement until another professor showed him some data that made him question. Since then, Tom has been working hard to spread the truth about man-made global warming, and the simple truth is, it's a lie. Tom joins me today with the real data on climate change and proves that not only is man-made global warming a complete myth, but that the actions which are being taken by governments around the world to save us all from this non-existent threat could in fact result in severe environmental repercussions. Mr. Harris gives us the real data, which shows that a new ice age may not be more than 1,000 years away, and shares his concerns that attempts to address the global warming lie could in fact result in that new ice age starting not in 1,000 years, but before the end of this century. Indeed, as the global warming alarmists claim, we are running out of time to wake people up.
You know, it is interesting. The whole issue of clouds, it just indicates how little we understand the environment and how little we understand the atmosphere, because clouds overall, generally speaking, cause about 10 times more climate change than all human activity combined. You know, so if we don't understand clouds very well, and we don't, then how can we tease out of the data the impact of humans? I mean, it would be kind of like having a radio signal come into us where we had so much static. There was actually a signal in there somewhere, but we couldn't hear it because there's so much static. And that's what's happening right now. And you know, I'll just point out one other quick thing. There's a new evolving field called cosmoclimatology. And it's based on understanding not just the impact of the sun, but the impact of our position in the galaxy. Believe it or not, that is a driver of climate change. And I'll explain how it's relevant to today. Okay, this is an amazing field.
I'm glad you're bringing this up, because my next question was going to be Milankovitch cycles, which I assume play into this.
No, actually, they don't.
No?
Milankovitch
Okay.
cycles are something different. And of course, that has to do with the orientation of the Earth.
It's distance from the sun and our tilt and all of that. And I've always understood that was really what was causing the ice ages. But if I am wrong, please correct me.
No, you're completely right. And the glacial periods, you know, like the last one 25,000 years ago, which lasted for about 90,000 years, and that is largely a function of the Milankovitch cycle. Okay, the changing in the ellipse of the Earth's orbit, the changing of our orientation, our axis, things like that. Those are the Milankovitch cycles. But this is a totally different thing. And it actually operates on much larger scales, time scales, and also much shorter time scales. And I'll explain why. Milankovitch cycles, of course, operate over thousands of years, tens of thousands of years. Now, in 2003, a paper was put out called a Phanerozoic driver of climate change. And I was given the job at the company I was working for. I was working for a communications company, and we were putting out science communications. My job was to understand this paper well enough to translate it into layman's language. And it was written by Dr. Jan Weiser from the University of Ottawa. He's an earth scientist, he's a geologist, and he had made a really amazing discovery. He found that over that period of about 500 million years, the temperature varied in a sinusoidal curve, which massive long periods that would last for tens of millions of years. So he wondered, what is it that drives temperature in a sinusoidal curve? Every tens of millions of years, we'd see a new period, a new cycle. And he had no idea what it was. But a scientist by the name of Nir Shaviv in Israel was looking at the cosmic ray flux. He was looking at iron isotopes, I understand, and he was seeing actually the same curve. It was showing a cosmic ray flux. Now, cosmic rays are interesting. They're not rays, first of all. They were named at a time when people didn't realize they were actually particles. But if you have a supernova blow up, it throws out lots of stuff into space. Now, it turns out that galactic cosmic rays, when they come into our atmosphere, interact with air molecules and they ionize them and they cause clouds to form. Okay, so what happens is this: at a conference, and they put their curves on top of each other. There's Near-Shaviv's curve of galactic cosmic rays and Weiser's curve of temperature, and they matched perfectly.
Wow.
What they found was that when galactic cosmic rays were high, we were in very cold periods on the Earth, and this would last for millions of years. These were called cold houses. The arms of our galaxy are what are called density waves. They're not a fixed structure. They're as if you were in a helicopter looking down at a traffic jam in the highway. When we go through the galactic arms, there's a lot more stuff that's close to us. Okay,
Yes.
it's like we're in a traffic jam, and so we're closer to nearby supernovas. So when we go through the arms of our galaxy, we're actually increasing our galactic cosmic rays, and that was the curve that Near-Shaviv found. As we went through the arms of the galaxy, it would increase more and more cosmic rays, and then it would be less when we're between the arms of the galaxy. Weiser found that when we went through the arms of the galaxy, our temperature was lower, which is exactly what you'd expect, because more galactic cosmic rays, there's more clouds, it would be colder. And so they realized that there was an actual, not just off-world or off-solar system, there was a galactic driver of climate change on a scale of tens of millions of years. Now, people said, oh, what the heck does that have to do with today's climate change? You know, it's interesting scientifically. Well, it actually has a lot to do with it, because what it showed is that galactic cosmic rays very much affect the Earth's temperature. When the sun is more active, it puts out a stronger magnetic field, and that tends to block off galactic cosmic rays. Okay, so two things happen. When the sun is more active, you get more incident radiation, which is called insolation. You get more incoming energy from the sun when the sun is more active. But you also get less galactic cosmic rays because the sun's magnetic field is stronger, the solar wind is stronger, and it tends to block a lot of the galactic cosmic rays coming into our solar system. And so you actually have less clouds being formed. And that magnifies the temperature change that would ordinarily happen only directly because of the sun. And some scientists are saying that most of the warming in the last century could be a function or could be caused simply by this solar effect. 2/3 of the warming could easily be caused by that. So that would only leave about 1/3 of the warming for all the other factors, including human CO2. So, you know, they tested in CERN in the laboratory there in their big accelerators to see if, in fact, galactic cosmic rays are simulated. And they said, yes, it does. It causes clouds. It's not just the long-term, you know, ice house, cold house period, the galactic cosmic rays are affecting the Earth and temperature. It's also on the short term, because as the sun is more active, you have less galactic cosmic rays that can hit our atmosphere. You have less clouds. It amplifies the warming. Similarly, when the sun is less active, of course, the Earth would be a little cooler just directly from that. But also you have more galactic cosmic rays that can come in, hit our atmosphere, and form clouds, which magnifies the cooling. So it turns out this is a field called cosmoclimatology, and it can account for most of the warming in the last century. That's a new field. And it is interesting that when the sun was actually quite weak, skies were very cloudy. Now, a lot of people thought that was just artistic license. But the current thinking is that it really was more cloudy in the Little Ice Age because the sun was less active and we had more galactic cosmic rays forming clouds. So it's a bit of historical evidence that, yeah, it's the sun is a major driver of climate.
So I want to finish with these really two questions. One, based upon your extensive knowledge of this, and you've studied this in great depth, would there be any temperature change that could happen, even naturally, that would present a real problem for us on any kind of short-term timescale? And two, is there anything that humans could be doing that would cause that?